Hello, and welcome back to Teacher Gimbel's channel. Today we're going to be going over Illustrative Math, Geometry, Unit 2, Lesson 3. If you like this video, please make sure to like and subscribe on the button that's right about over here, or maybe it's over there. Also, if you haven't yet, if you're a student, teacher, parent, or anybody who's part of a school, go to our new website, www.rateyourprincipals.org, to check out your principal and see how they're doing at your school. Alright, let's get started. Problem number 1. Triangle ABC is congruent to triangle EDF. So ABC is this guy. And I'm going to write this out. Triangle ABC is congruent to triangle EDF. Okay. So Kieran knows that there is a sequence of rigid motion that takes ABC to EDF. I know there's a sequence of motion that takes ABC to EDF. Select all true statements after the transformation. Now, we're going to actually use this statement to help us note a few things. Do you see how A is in the first spot? That means angle A is actually congruent to angle E because it's corresponding. So ABC corresponds to EDF. So A corresponds to E. Angle C corresponds to, so therefore is congruent to angle D. So I'm going to make 2 marks right here. And finally, angle F corresponds to and is congruent to angle C. I'm going to make 3 loops right here. And I'm going to erase this little arrow so you can see a little bit better. I possibly will erase this arrow. There we go. So the order of the letter matters. So let's talk about our question choices. Angle A coincides with angle F. Well, angle A does not coincide with angle F, so we cross them out. Angle A goes on top of angle E. Angle B coincides with angle D. Yup. Segment AC corresponds with segment EF. Well, AC, does that match up with EF? We go from 1 loop to 3 loops, 1 loop to 3 loops. That's true. And we can actually say AC corresponds to EF by looking at our statement too. So that is true. Segment BC coincides with segment ED. BC coincides with DF. Not true. Segment AB coincides with segment ED. AB, ED. This is true. And we can see we have AB right here and ED right there. And we're done. Pause this video if you need to go over it. And I'm going to go on to question number 2. Problem 2. A rotation by angle ACE using, a rotation by angle ACE. So we have ACE using point C as a center takes triangle CBA onto triangle CDE. So CBA got rotated, so he lines up with CDE. So that means like this line right here lines up on this line right here. This line, make it squiggly, lines up on that line. And then finally, AB would line up on ED. Explain why the image of ray CA lines up with ray CE. Well, I'm going to erase this so we can see this a little better. Remember, we're rotating. This triangle is going this way. And we have CA is going to line up with ray CE. Well, this is the side that corresponds when we do that rotation. CA corresponds with CE, so they're going to line up. Explain why the image of A corresponds with E. Well, A is at the end of CA, and he's going to go ahead. If he lines up with CE, he coincides on top of E. And finally, is triangle CBA congruent to triangle CDE? Well, they used a rotation. A rotation is one of our 3 rigid motions, which is rotation, reflection, and translation. And if it's rigid motion, that means it's congruent. We're done. Let's go on to the next question. Problem number 3. Oh, this got a lot of reading. The triangles are congruent, so this guy is congruent to that guy. Which sequence of rigid motion will take triangle XYZ onto triangle BCA? So I'm just going to write this out because XYZ is going to go on top of BCA. So I know X goes to B, Y goes to C, Z goes to A, because that's the order of the letters. And I'm going to now look through all of my answers. Now visually this might be difficult, so I might recommend you go get a piece of tracing paper if that's going to help you figure this out, because I'm going to try to draw it best I can, but tracing paper kind of is the way that you could do this on your own screen. Triangle XYZ using directed line segment YC, or translate triangle XYZ. So XYZ is moving. We're going to use directed line segment YC. So that means Y is going to come down here, and we're going to end up with a triangle that looks like Y prime, X prime, Z prime. We just slid him down. Rotate X prime, Y prime, Z prime using C as a center so that X prime corresponds with B. Okay, so I'm rotating so X prime corresponds with B prime. Well, does that work? Does XY, will XY line up perfectly with BC? Well, XY and BC, it would line up. So then this triangle, I'll use a different color, is kind of lining up right like that. And I had to double check, sorry, that's a little bit sloppy. I had to double check that this line right here is the one that corresponds. Now finally reflect the triangle across CB. Well, if this guy gets reflected over there, they're going to line up. So this guy is good. I think this is a multiple choice question, which means we're actually done. So let's go ahead and check one more of our answers and see if that works. Translate XYZ using directed line segment YC. So the same thing. He's sliding on down. Made him a little bit more organized this time. We have Y prime over there, so we slid him down just like we did before. Remember last time we rotated him up, so we did that. Now we're rotating X, Y prime, Y prime, Z prime using C as the center so that X prime corresponds with B. So we rotate him up again like this, so they're going to be lined up just like last time. And now we are reflecting across line AC. Well, if he's our line of reflection, this pink guy is going to end up somewhere like that, which is not on top of ABC, so that is not the correct answer. Now, before I erase everything, we're translating again using YC, so we just did that. We're rotating using the center, so X prime corresponds with A. Well, that means we're rotating him so this side actually lines up over here. Will X prime ever correspond with A? I actually don't know the answer to that question. And then reflects XYZ over line CB. Well, then he's going to get reflected and flipped it over there, so nope, that's not going to work. And then finally, we're translating using directed line segment YC again, so he's down there. Rotate X prime, Y prime, Z prime using C as a center so that X prime corresponds with A, and reflect him across line AC. So we're rotating using C as a center so that X prime corresponds with A. So this side is going to line up, so we're going to have X prime right here, and that means it's going to kind of look something like that, right? Because we rotated this guy all the way up. That's going to be our Z prime. Our Y is going to stay right there because our Y stays at the top of C because that's the center of rotation. And then we're reflecting across line AC, so he's going to go up over there like that, and that does not get our reflection. So our correct answer is answer A. Now again, this is a lot easier if you do this with a piece of tracing paper. I do it off the top of my head by drawing, which works if you can visualize that, but definitely try to get your piece of tracing paper to help you visualize that if you had a hard time. Problem number 4. Triangle HEF, so we have HEF, is the image of triangle FGH. So FGH after 180 degree rotation around point K. So he got rotated all the way around. Select all statements that must be true. Now I'm going to do something, I think in the last video I did a similar question, but I'm going to do something a little bit different here. So that's our HGF. Now GHF started down here and got rotated around, which means our G ended up top, and then H is actually going to end up over here, and F is going to end up right there. So these are the two congruent triangles that we have. and we have HEF, triangle HEF, is going to be congruent to triangle FGH. And that's going to help us see which ones of our answers are correct. So it was triangle HGF, congruent to triangle FEH. Yes, that is true because it's a rotation. Rotation is one of our three rigid motion: translation, rotation, reflection. Therefore, the triangles are congruent. Is triangle GFH, oh, I did the same thing last time. This isn't about if they're congruent. It's also about, do our angles match up? So HGF, so is congruent to FEH. Well, in this case, HGF is congruent to FEH. Yes, our triangles match up, and it's rigid motion. What about this one? GFH. So GFH should be EHF. And in this case, it's EFH, and those order doesn't matter. So it's like 1, 2, 3 matches 1, 2, 3, because that's the order I went in, 1, 2, 3, and that's not the order here. So, no, they are not congruent. Now, is angle KHE congruent to angle KHG? Let's do this a little bit of a different way. K is going to be in the middle of both of these. So is KHE, well, this side would have to be congruent to KFG, not this side. So no, because they're lined up this way. Is angle GHK congruent to angle EFK? Yep, these sides match up. That is correct. Is segment EH congruent to GH? Well, EH is right here, which matches with FG, and GH is over there, so no. And you can see EH matches GF, not GH. So the letters match up too. Finally, is segment HG congruent to segment FE? Yep, they're in the same spot, so they are congruent. So you can use your letters by looking HG, the last two going this way, is congruent to segment FE, the last two going that way, or you could kind of imagine them being on top of each other, so EF is going to have to be on top of GH, HE on top of FG. You need to figure out which way you can visualize that's best for you, and both of them work. Remember, your corresponding parts of congruent triangles are always going to be congruent, but they have to actually be corresponding. Problem number 5. Line SD is a line of symmetry for figure ASMHZDPX. Okay, so we've got a line of symmetry right here. A line of symmetry means it's actually one side can be reflected on top of the other. Tyler says that ASDPX, so ASDPX is congruent to SMDZH. Now here we have an issue here because we're going SMZ. That's not the order of this shape, which actually creates a different shape because sides AS and MS are corresponding. So he's saying, well, these two guys, AS matches with MS, therefore these two figures are congruent. This is not a good congruency statement because our letters don't match up. So let's go ahead and figure out the correct congruency statement. So that one's not good. Let's erase all of this. Let's try to erase all of this. Let's have a problem with erasing all of this and figure this out. So we are going to start off with Tyler's ASDPX. S is congruent. Well, we went A to S, so we'd have to go M to S in this case because those are the sides that match up. And we have to go to D, and then down to Z because the Z and the P match up, and then to H. So that would be our correct congruency statement. All right, pause this video if you need, and we're going to go on to the next question. We're going to try to go on to the next question. Oh! And let's go. Problem number 6. triangle ABC is congruent to triangle DEF. Okay, so ABC, DEF. Select all the statements that are a result of corresponding parts of congruent triangles being congruent. Is AC congruent to segment EF? AC, DS. So I already noticed that this is like a reflection here, which helps me figure out which sides are corresponding. AC, EF. Well, AC matches up with DF, so nope. BC is congruent to EF. BC, yep, matches to BF, so they're congruent. Angle BAC is congruent to EDF. Yep, those angles are congruent. Angle BCA, this top guy, is he congruent to angle EDF? No, he's congruent to the angle that's up here. And then finally, angle CBA, this guy, is he congruent to FED, that guy? Yep, because they're corresponding. All right, that one was easy peasy lemon squeezy. We're going to go on to the next one. And if you need help, or didn't find it easy peasy lemon squeezy, make sure to pause the video and rewind so you can look it over. Problem number 7. When triangle ABC is reflected across the line AB, the image is ABD. So we got ABC, he's reflected, and he lines up with ABD. Why is angle ACD congruent to angle ADB? So why is ACB congruent to angle ADB? Well, we know that a reflection is rigid motion. Rigid motion preserves two things, the measure of the sides and the length of the angle. So if C got reflected, which is rigid motion, then angle C is going to be the measure of angle D. Let's figure out which answer says that. Corresponding parts of congruent figures are congruent. I believe it's this one, because it's rigid motion, because it's a reflection. It is congruent because it is rigid motion, and they're corresponding. Let's see. Congruent parts of congruent figures are corresponding. They keep on putting this as an answer choice. It doesn't actually make sense to me. So it's not congruent parts of congruent figures are corresponding. It's corresponding parts of congruent figures are congruent. So be careful about that when you have these answer choices. Segment AB is a perpendicular bisector of segment DC. That has nothing to do with angle D, nothing to do with angle C, so we're going to cross them out. Finally, an isosceles triangle has a pair of congruent angles. Yes, that's true, but in this case, we don't know if this is an isosceles triangle from the beginning of the question. So we can't use that to prove this fact. What we do know is that it's rigid motion, it's a reflection, it has a pair of congruent angles, and then actually we can prove that it is an isosceles triangle. But that's not enough information from the jump. So we're going to go with question A, or answer A, being the correct answer. Problem number 8. One of these parallel line questions. I love these. Line DE is parallel to line BC. Let me move over a little bit. What is the measure of angle EAC? What is the measure of angle DAB? So DE, I always like to trace it. Well, that was too many lines. So we have DE. That was too many deletes. Is parallel to line BC. So I'm going to draw little arrows to denote that they're parallel. What is the measure of angle EAC? E, where's the E? That's the E up there? Yeah, that's the E. EAC. So I want to know the measure of this angle right here. I notice that I don't actually have any numbers here, so I'm just going to have to use what information I have. Now, whenever I have a parallel line, that is a loud notification of saying, look for transversals. Now, the reason I use this line as a transversal is because I noticed I needed this angle, so I chose a transversal line that dealt with that angle. Immediately, I see a pair of alternate interior angles, which means the measure right here is going to match the measure of its alternate interior angle down here, which if this is C degrees, then that is also C degrees. We're done. 2. What is the measure of angle DAB? Now this is a little more complicated, but we are mathematicians, so we're going to get it. We want the measure of angle DAB, which is right here. And I'm going to go ahead, I'm going to say, I see I have another transversal. Oh, So it's actually not as complicated as I thought it was going to be. And I'm going to draw this parallel line in blue so we can see it. And I say, I want this guy right here, question mark. Well, I actually notice he's alternate interior with that guy over there, so his measure is B. And we're done. Alright, pause this video if you need to go over to any questions. I hope to see you in the next one. Make sure to like and subscribe if you like this. The button should be down here somewhere. If not, it's underneath the video. And also check out our new website, rateyourprinciples.org. We'll see you in the next one.